Okay, this is problem number 4 from stoichiometry section 3, and it's hydrogen gas plus bromine gas react to form hydrogen bromine gas. And this is already the balanced equation. So part B says 3.2 grams of hydrogen gas. We'll have our 3.2 grams and 9.5 grams of our bromine gas react. What is the limiting reagent? So to first find this, we want to talk about finding the molar mass. And to find the molar mass, we know that our formula for moles equals grams over formula mass. So for each one of these, we know that our molar mass for hydrogen, it's just about 2.016, and the molar mass for, or the formula mass, molar mass is the same thing. For bromine 2, it's 159.8 grams. Okay, so we'll divide both of these numbers to get the moles. Okay, and so, and our answers are 1.59 moles for hydrogen 2, and we'll get 0.0594 moles for bromine 2. Okay, now that we have found our moles, we know that since 1 mole of hydrogen reacts with 1 mole bromine 2 is going to be the limiting reagent or reactant because there is less of it. So we know right now for our answer, because it says on B, which is the limiting reagent, it is going to be our bromine 2. So now if we go to move to part C, it says how many grams of hydrogen bromine gas can be produced using the amounts in B. So since we have bromine is the limiting reagent or reactant, we're going to use bromine for our calculations. So we're going to say and we want to know that the molar mass of our HBr is 80.91 grams per mole. Okay. So now we want to find how many grams this is going to produce. How many grams the bromine is going to produce. So we will start with that 1 mole of Br2 produces 2 mole HBr, because we see the 2 for the moles. So we know the molar ratio for every single one of these, there's 2 of these. So we're going to take this number and we're going to divide it in, or we're going to multiply it by 2, because one of these is 2 of these. So 0.0594 mole times 2, because we're doing molar number, is 0.119. Okay, so now we know how many moles of hydrogen bromine are produced. And now we're going to convert to grams. And we know moles is grams over formula mass. So we'll just rewrite this equation, and we're going to multiply moles times formula mass now equals grams. So 0.119 times the formula mass, which I said earlier was 80.91, equals 9.61 grams HBr. So that is your answer for part C. Then it says for part D, it says how many grams of excess reactant is left unreacted. So we know in the beginning that we said we had 1.59 moles of H2. And we know that we had 0.0594 moles of Br2. So we're going to subtract the 0.0594 moles from the 1.59, because since we know that the molar ratio is equal, since we only use this many moles of Br2, we're only going to use this many moles of H2. So when we subtract them, that will be our excess. And our excess, which subtracted, that's 1.53 moles H2. Okay, And then with our 1.53 moles, it wants how many grams. So again, we're going to be transferring moles into grams. And again, moles going into grams, so you multiply by the formula mass. So when you multiply by the formula mass times 2.016, which we said earlier was the formula mass, you will get 3.09 grams, which is your leftover H2, which is your answer to part D. Then for part E, it says what volume of HBr measured at STP is produced in B. So you need to know that one mole equals 22.4 liters at STP. Okay, so we have, again, we said that we have 0.119 moles, so that's 0.119 mole. And then we're going to multiply it by 22.4 because we know we do not have an entire mole, so we will multiply it to find how much liters we actually have. So we're going to multiply by liters, and then, so the answer is 2.67 liters. And this is your total volume that HBr produced. So I hope this helps. Thanks for watching.